So I have my axis here, and I want to talk about wavelengths. Okay, we're going to start with electromagnetic or visible waves. Okay, light rays. Light rays are electromagnetic waves that basically travel in the absence of a medium or through a medium, depending on the thickness of it. And we actually process that in our eyeball. Okay, now, we know the 7 colors of our spectrum. Roy G. Biv. So red, orange, yellow, green, blue, indigo, violet. So if I look at a red wavelength, I got bright red here. Because red is at the beginning of the visible human, light spectrum, so that's going to have a big wavelength. All right, now, a wavelength is a complete cycle of a wave. It means it starts at one point, it will rise, it will go back to its medium plane, it will go down by the same amount and come back to that actual plane. Okay, this is your first cycle. Then we begin cycle 2. Okay, so a wavelength is a complete cycle of a wave. Now, if I'm talking about a different color of light here, so let's say a blue light, okay? A blue light actually has a shorter wavelength than a red light because the red wavelength is longer in distance. It actually has a longer undulation, okay, or above the axis, below the axis, than a blue one does. So if I pick blue here, and we'll have the same starting point, and I'm going to try to do the same amplitude. So if we go up, and we go down, and we go up, and we go down. Okay, so you'll notice that in order to complete a wave with the blue, I'm done my first wavelength here. The distance to my blue wavelength is shorter than the distance to my red one. Okay? So when we talk about wavelength, we're actually talking about the length it takes it for it to do one cycle, for it to complete one cycle. And wavelength is actually measured in meters. Okay? And then we're talking like nanometers because like 1/1,000,000th of a meter here because it's so tiny. Okay, and I think nanometers are even smaller than that. All right, now, so if that's the difference between wavelengths, all right, for light, let's talk about the different shades of light and how we actually get those shades depending on what color we're actually talking about. So if I hit my blue here, and I'm going to look at a lighter shade of blue. Okay, this blue is a lot lighter than the original blue I had. So the shade or the intensity of the color is actually determined by the amplitude of the wave. And the amplitude is the height from that principal main axis, okay, and height being positive or negative here, it's absolute. All right? The amplitude is how high up away from that center axis that the actual wave goes. So when I'm talking about a light blue versus a dark blue, they both have the exact same wavelength, but what's different here is their amplitude. Okay? So if I choose that blue, notice how I'm crossing at exactly the same places here, but my amplitude is much lower. Okay, this one versus the tall one up here. And the same can be said for sound. If I sit here and I actually do the exact same thing for sound, now a sound wave is a mechanical wave. You don't have a medium, the sound cannot go through the medium. Okay, you need, the thinnest medium we know of is air. Okay, sound travels, mechanical waves travel quite well through air. So if I actually draw And I'm not even going to use colors here because I don't want to throw you off. Okay, but if I have a sound that has a really big wavelength, okay, that wavelength, it takes it a great distance here to get through one cycle. That has everything to do with pitch. So the lower the note that you're hearing, the larger the wavelength. So somebody with a really deep voice, or when you're tapping on piano keys and you're hitting the ones down towards the left side of the actual keyboard, those have much larger wavelengths than those really high-pitched sounds. Okay? So a high-pitched sound, we're going to try and go through the same wavelength here, but a high-pitched sound will actually have the same height, but it'll actually be much shorter. Okay, so this is a high-pitched sound. We actually get through one cycle in this distance versus one cycle all the way here. When we talk about a sound wave, we know that the wavelength, so the distance that it takes for a wave to complete one actual cycle, actually talks about the pitch or the note of the actual sound. My voice has a note. But when I'm being stern with you and trying to capture your attention, I might raise my voice, but the pitch of my voice might not change. Okay? And when we actually adjust for volume, whether we lower our voices or we raise our voices, what we're actually playing with in a sound wave is we're actually playing with the amplitude of the sound wave. So the higher the amplitude, the bigger the volume. Having a really low voice like this and speaking really softly, I'm still keeping the same pitch, but my actual amplitude is much less. Okay? Whereas if I have really high volume, my amplitude will be greater. So for light and sound, amplitude is going to change the shade of color in light. It's still going to remain blue, but it might be a light blue. Okay? Whereas in sound waves, amplitude will change the volume. It won't change the note. It won't become higher pitched or lower pitched, but it might become softer or it might become louder, depending on the amplitude.